this thing on? Yeah, looks like we're on. Alright, cool. What do we got today? Discord is a black hole for information. Could be good. 1970s board game takes 1,500 hours to compile. Yo, what's up? Hey, Michael. What's yes? Ass hacker knows that I don't care if it succeeds. What gambling firms don't want you to know and how they keep you hooked. Tech firms are getting desperate. Let's see. Hires people. Pool of candidates. Yep. Yeah, they're getting big salary packages. Yes. 30% when sought out a new job. These are the highest amongst industries. Oh, I asked if this thing is on. Yeah, thanks, man. Yeah, this is true. This is somewhat true. There is a shrinking talent pool. I know a lot of people did quit. Yes. Show us your leave. So I'm gonna be chatting with a new client today potentially. What happened is, he reached out to me. He's saying, hey, he wants to potentially do long-term coaching. So we're gonna spend the first 30 minutes of the stream, chatting with him. Hopefully he's a fit. Seeing if I can help him. And then we'll go into the main content, the coaching session afterwards at 11 a.m. PST. So let me actually write the schedule in the, what's it called, the comment or the description. Okay. I will say that. Let me finish reading this article and I'll give you my thoughts actually. Because I think this is actually a lot more interesting than people think it is. It's like, okay, people are offering a lot of money. Yeah, pays interview finalists 500 each. No one cares. Da da da. A golden hello is such a tough call because people are already in the business of saying, hey, I didn't see one of those. Da da da. We need to be extra competitive. So shout out bonuses have been effective. Other employees are in a similar situation. We hire when we can. It's a great opportunity. The reposts early shareholders acknowledge that rejecting remote work will cost them dearly in the fight for talent, where Facebook, Twitter, and Shopify have made it a norm. Apple has not. Apple has made it somewhat a norm. It's like you're allowed to do half and half at Apple now, at least to my knowledge. Median salary rose almost 7%. From a report, averaging 6,700 months per employee. Average salary for a knowledge worker is 104,000. Interesting. Okay, this one's an interesting tech salary report. All right. Average tech salary is 6 figures. Yes. Oh, okay. I guess I'll look at this report later. But I'm surprised that it rose 7%. This one's interesting. But here's the reason why it's more interesting. I'm gonna start off with like a story. Basically, the past few weeks I have been interviewing people at Uber, for a potential L5 role, an L5B role, which is like a staff level role at Uber. The problem we're facing, and I would say the common reason why I've rejected candidates, and I think most people have rejected candidates, is that people straight up just copy whatever they've seen at these big tech companies and just kind of say, oh, that's the way it is. That's the way it must be. We are going to just use that as the solution to these problems. So for example, let's say I give you a system design question, like, design tiny URL. And instead of going through the trade-offs of like different structures, you instead just copy paste whatever you see at work. Now, this leads to a problem because, well, that means that if we know what we're looking for, especially at the L5 plus level, then we're smart enough to know that you're just copy pasting tech stacks or code without actually thinking through it. And turns out there is a non-insignificant number of people at Fang, seriously, Fang, that do this. Like they interview that way and they get offers that way, and it's like also it's and they are relying on the brand name of their experience to carry them through it. Now, this was pretty much known, but only at like the lower end of engineers, the people outside Fang. We kind of assumed that they would do that. But what ended up happening, and this is something that blew my mind, is that these are people at Fang who are technically technical leads in their teams and have been in the industry for 10, 15 years. And they're still doing this. And it's mind-boggling to me. I don't understand why this is happening. At the big tech companies, actually, it's really bad. At least from my experience. And so the median salary does rise, but I'm wondering, there may be like a few factors that are skewing this. The first one is that the people from the big tech companies might be going to small tech companies or just straight up leaving for various reasons. Great resignation and all that. It's like, oh, I want to work at a startup. Fine. So that could, and because they're riding on the brand name of their past experience, they are basically going to be hired at these smaller companies or lesser known companies, lesser brand name companies for much more pay, because you need to compensate for it with equity. So that can actually contribute to the 7% rise. The other thing is that if you're trying to go the other way around, getting into these big companies, the bar has never been higher because, and I mentioned this before, I think the bottom 30% are leaving. The top 30% are leaving. The bottom 30% are trying to take their spot, but then realize that they can't, and so they just kind of give up and go to a startup, realizing that they can't get back into the golden walls. And that's my theory of what's happening. But I only expected this to happen at the smaller companies, not Google, not Facebook, not even Amazon. Well, Amazon kind of, but you get my point here. The problem is much more prevalent than I had originally anticipated. Hey man, what's up? And so I think some of you might have seen a message on my Discord saying that there are a lot of bad content out there that people don't know what they're talking about, and there's like literally a shit ton of coding interview content that is absolutely useless. So if you look at like coding interview 2022, right? It's like your ultimate. Let's pick this random one. I've never clicked on this before. Your ultimate guide, blah blah blah. Like, why do you need this much information to say how to stand out over the phone? Like what? Like, practice your enthusiasm, get a cultural fit, blah blah blah. I don't understand. Nothing in quote 2022 is any different from what's in 2018. I don't get it. Coding interview prep, 30 per second, 1 minute elevator pitch, dynamic programming. Yeah, this is all useless. It's all useless information. It's literally just a cloning of other existing material that's out there. And all this was known like 5 years ago. So I don't know why it's quote unquote modern now to rehash this content. It's like the content's being recycled and then resold. It's really shit. It's kind of pissing me off, and I'm really trying to figure out why this is actually happening. Because I kind of figured people should be better at this, but no, people are actually worse over time. Like this issue has gotten worse over time, and I don't know why. So let's actually bring on the client and let's chat with him. Oh wait, I didn't give him a Zoom mail. The heck? Why did Zoom not?
Recording in progress.
Okay, so I'm gonna.
Recording stopped.
So let's bring him on. Let's see what happens. No, what the heck is going on here? What is going on? Oh my goodness. Yo, what up? Hello?
Hello.
Hey, what's up?
Hi, I'm good. How are you?
Hey, I'm doing good. Yeah, thank you for reaching out. How'd you find out about me?
Ah, me and my wife were just Googling about coaching sessions, and actually, she's the one who found out about you through Google.
Hmm. Okay, yeah. Um, yeah, so let me know. So right now, this is going to be a chat, potentially working long term. The way this goes is that I'm just trying to see if we work together, if we share like similar values, and more importantly, if if we are in that case, then I will potentially have you like sign on as like a long term client for long term coaching. This isn't like an obligation to sign up here. It's just really just a get to know you thing. Sound good?
Yep.
Yeah. So give me a little rundown of your situation and how you think I can help you.
Okay. So, uh, as I wrote you already, I have almost 8 years of experience in software development.
Mm-hmm.
I started my journey with SAP itself, and I was there in Bangalore earlier, and then 3 years back I moved to Germany.
Mm-hmm.
And right now, so I'm looking for a job change, especially to Google and Microsoft,
Mm-hmm.
primarily Google actually. And there are. Would you like to also know the reasons why I'm looking for a job change?
Yeah. But keep in mind, like, don't need to be too personal about it.
Okay.
Just give me the rough
Okay.
details.
Okay, so two things. One is I don't find my role or my work at my company to be challenging enough. I tried for several years to get into projects where I can do more problem solving, have complicated problems to solve, or at least they are designed in a way that you have a lot of, for example, users where you have to design a complicated system, a
Mm-hmm.
scalable system, or a distributed design. So that was my interest, and unfortunately, I couldn't land into either a team or project that does. So now I think for this, and also I want to basically earn more.
Got
So
it.
these are the two.
So you're looking for a challenge. You just want to earn more. That's pretty typical. Now you said you've been study. You said you've been trying for a while. If I remember, did you say that?
Sorry, what? Come again?
Have you been trying for a while to get into?
No,
Okay.
no. I haven't even, I would say, started preparing it, and that's why I thought that it would be good if I have someone whom I can consult, because otherwise, maybe, yes, there are resources available online, but it's good if you have a person who's guiding you so that it doesn't take, instead of, for example, if it in general takes for me 1 year, I don't want to spend the time that, not the knowledge that, for example, you already have, and finding that out over internet.
Mm-hmm. Okay, that's fine. But I have you read my guide?
To be honest, not full.
Okay.
I started with it, but I couldn't complete it.
Okay. Well, that guide basically lays out how to study, actually, how to think about coding interview problems, and everything else. It's literally everything I do on this. I do it for all my clients, the blueprint of it. So I highly
Hmm?
recommend you actually read it because then you'll understand like where my philosophy comes from, why I think the way I do, and what I say, what I do. I want you to at least give it a fair shot. At least like do what's in the guide, and then try
Hmm?
it out yourself before we chat again. Because right now,
Hmm?
let me tell you where I'm coming from. Right now, I want to work with people who have at least understood why I do what I do and understand the content that I produce. And the reason why is because, like, I'm a very tough person. I'm very tough. I'm a very tough coach. But I think the results that my clients get speak for themselves. So the
Hmm.
worst thing for me is to have someone who does not want to try very hard. Like I'm literally asking for at least like 20, 30 hours a week from you and of like actual hardcore studying. And only for like maybe
E
6 to 8 weeks. So I don't want to have some client just quit on me in the middle. That would be a very
Hmm.
terrible situation for me to be in.
Yeah, I agree. And yeah, I skimmed through that part of the initial pages, and yes, I got the idea that yes, you see that ultimately it's the practice, but in the right direction,
Mm-hmm.
and kind of achieving perfection to know how to solve problems,
Mm-hmm.
understand the patterns, and basically develop the patterns so that even if something new is coming up, you can do that. And to be honest, right now I am ready to spend at least I would say 20 hours a week. I already planned time about this, and I say if even if it requires like 3 months or 4 months, that's fine for me.
Okay, that's fine. But like everyone talks the talk, I want to see you walk the walk. So for now, I'm gonna
Sure.
say let's hold off on it because
Hmm.
I'm not convinced. And I want you to at least give it a try because once you go over
Hmm.
the resources and and if I can see that you made the effort, maybe you won't even need me. And I'd be very happy with that as well. But let's say let's reschedule for 3 months time to chat. And say, okay, well, you gave everything in the guide a fair shake. You've tried all the resources out there, and you're still convinced that I'm your best shot. Then
Hmm.
I'd probably be happy taking you on. But until then, it's a no. So I'll reschedule this chat
Hmm.
for 3 months out. Does that sound good to you?
So you think that going through the two primary, I guess, materials that you have suggested would take 3 months if done 20 hours or 30 hours a week?
I would say like even with like grokking and systems. So there's two parts to the guide, right? The first
Hmm.
part is in elements of programming, interview, and grokking. That's your data structures and algorithms portion.
Hmm.
Then you also have your system design portion. So at bare minimum, you're spending 3 months because it's six
Hmm.
weeks. Like in my experience, it takes 6 weeks to get very good at the algorithms portion, but then a little bit longer than that to get very good at the system design portion. But since you've been in the industry for 8 years, you might be able to get away with 3 months. So 6 weeks, 6 weeks for each portion.
Hmm. And what if I also need like help during this time when I'm practicing and learning?
Okay. If you need help there, I offer like the one-off sessions as well.
Hmm.
So it's like, oh, I need help learning about this. Just give me. I need 2 hours of your time. There's a section on my website that you can just book me for a one-off session like that. The reason why, and I think the reason why I'm doing this and is because I like not only is because it's like I don't want a client to drop out on me, but also I think you get far more value out of just trying to work with me for like maybe 1 or 2 sessions instead of going for the long term thing because my comp like I'm very expensive. I'm not gonna lie, like, but I think I'm worth every penny. But the thing is, I'm not gonna work with someone who isn't gonna get that kind of value out of it because like I take a 10% stake in your outcome, right? And that
Hmm.
adds up a lot. That's a lot of money. I'm not
Hmm.
gonna lie. So I'd rather the client really understand what I'm offering and at least try me out before they make the full commitment. That's at least what I believe.
Okay. And how much time like do you coach generally after, let's say, I'm prepared? How long does this coaching going on, and what are the further learnings during that journey?
So you're asking me like, what if you do the 3 months and then you say, hey, yeah, I still need your help. You're asking about that situation, right?
Hmm.
So the way that works is that okay, well, we would set up like a bi-weekly meeting. In fact, you can actually watch like my previous what's it called? My previous clients on YouTube. So you get a
Hmm.
sense of like what it entails. But basically, we would do 2 hours every week for coaching, and then we do a 1 hour replay analysis as well, just to make sure that you're practicing the right things. And we would do that approximately for 6 to 8 weeks, or however long that you need it for. I've run as long as 12 weeks for clients, but basically it just goes until we think we've exhausted every single possible effort. And if you are not able to get like a good offer in that time, then I just refund you all the money and it's all free. But that comes. There's a few strings attached to all that. But basically, that's what the long term coaching would look like. It would be basically 3 hours a week plus the 20-30 hours that you would spend on your own. And
Okay.
then one other thing is that I would basically be on call for you. So like if you
Hmm.
pinged me, I'd be responding within 24 hours.
Okay. And you charge the fees like upfront, or how is it?
So the fees in that situation would be like there's a deposit, and then at the end it would be based on your first year offer. So the deposit is just there to make sure that you don't run off on me. But the everything after that, once you get an offer that you're very satisfied with and that you want, then that's when my fee would kick in. That's it.
Okay.
Yeah.
Okay.
Yeah.
And uh, I don't think that happens, but just a question, like, what if a person doesn't get an offer, so you just refund the deposit
I would
and you
refund the
don't charge
deposit and
anything?
everything. Yeah, I have never had someone like not get an offer. Never ever.
Okay.
Like my hit rate, my success rate on any single interview for any client is like somewhere around 70-75% right now. So you pick
Okay.
so like literally you pick Microsoft, Google, Facebook, you have a 75% chance of getting an offer with long term coaching. That's at least based on my previous records. But past results aren't indicative of future results. But I'm pretty freaking sure that if as long as the client's willing to work with me and do what I say,
Hmm.
I can get them literally any offer in the world.
Okay. Okay. So you would suggest that I go through your preparation guide and
Mm-hmm.
practice based on that about the 2 or 3 courses in the book that you recommend,
Mm-hmm.
and then this should be at least sufficient to know all the problems, but the further things that will come during the coaching.
Yeah, and there's a very specific way that I practice that I recommend people practice in that guide. So I highly recommend
Hmm.
you follow it. If you have any questions that like you just need like me to answer it very quickly, feel free to shoot me an email and I'll respond. I'll respond for free. But yeah, I want you to at least give it a try, so that way you at least understand where I'm coming from. Because I guarantee you that everyone else in the industry is just like, oh yeah, I'm going to sell you some I'm going to sell you like information that you can get in a college textbook, and that's it. But for me, I specifically focus on thinking like a proper engineer and executing at a very high level, and that's going to be a completely different beast than I think what most people entail.
Okay. Okay. Sounds good.
Hmm. Yeah. So yeah, I'll reschedule this for, let's say, the does the second week of May work for you?
Just a moment. Yep.
Okay, cool. I will go ahead reschedule that for you. And then I guess, yeah, cool. And then I will forward this link to you and add you to the calendar.
Okay.
All right, cool.
Great.
Yeah.
Thank you.
Yeah, thank you, and good luck on studying. Let me know how things go.
Yep. Sure. I'll maybe just time to time keep on updating you.
All right, for sure. Take care, man.
Okay. Thank you. Have a good day. Bye bye.
All right, bye bye. Okay. Hmm. Well, I mean that happens. So I kind of wish that people would actually like read my guide before they sent me an email. To be fair, but sometimes this happens. All right. Well, we got like 15 minutes until he shows up. So hey, what's up? Hey, George. So we got another 15 minutes to hang out and chill until we begin the actual main content. Uh, all right. What else is on Hacker News that is worth talking about? Discord is a black hole for information. There's a variety of open source projects in the dev. Information, 9% of combinations. that take place in Discord are missed, so they get swept away in a never-ending cascade of chat messages. Yes. So thought on tech sales. What do you mean tech sales? I don't know what that means. I mentioned about the books to the last guy. What books do you recommend? So if you look at in the description, there's a guide. Welcome to the coding interview. You suck. That's my guide on how to actually prepare and study for coding interviews. So the two resources I recommend for studying is going to be Elements of Programming interview and Grokking the coding interview. So those between those two resources, you should be absolutely prepared for anything that comes your way. And if you're looking for books for tech prep in general, I have a video on my channel about that. It's Edbert. Alright. So I'll place that video in the chat. If you're looking for like books on your career in general. You know what, let's do this. I might as well watch some Dota. I haven't actually played Dota in like a long time, man. Holy crap.
Let me finish this.
How about system design for mobile engineers? Is grokking worth it or someone else? Okay. So for grokking, I don't even think grokking has a system design question for mobile. Actually, I think that's actually kind of that's actually the interesting part. So let's actually look at grokking the system design. Like literally, I'm pretty sure this only talks about like master scalability and system design. There's nothing for mobile, but the common patterns and I would say the common principles underneath the hood are pretty much the same. So if you understand the end-to-end mobile process of deploying a mobile APK, then you actually can just apply the same thinking, the same methodologies that you use for this system design to just that. So let me give you an example without like giving you an example that we actually use. So like for instance, let's say for instance, this is off the top of my head, let's do a lifecycle aware dependency injection tool. You know, how would you do that? You know, and so that would basically incur that you would need to know about how life cycles work on the mobile systems. And then you also need to know what dependency injection is, right? And then not only that, you need to ask yourself, well, what developers are using this tool? Who is our audience? Why do we need to care? And does this dependency injection work on the code level, or are we injecting something into the bytecode as well? And so it's like knowing and understanding every single aspect of the mobile development process. And in this case, it can range from simply architecture to the compilation of the APK binaries, to there's a whole bunch of other things as well. And I'm not doing this question justice, but the thing is that I don't even think there is like mobile system design interview. You would think like with mobile being out there for like so long, that there would be like some good resources out there. I'm just like I've not seen that. You know, like for instance, like non-functional functional requirements, like. This is not really. I mean, I guess this is like basic, but like, this doesn't actually tell you. This isn't really that good. No. Like, I mean, they're questions that you should ask, but they're not like end-to-end guides or courses on it. So you would think that with mobile development being so popular for the past 8-10 years, people would actually design a course for this, and I'm like. No, not really. I don't get it. I'm actually it's baffling to me. Okay, the API file downloader. This isn't really mobile. This is just simply client facing. Yeah, this is just client facing. This is not good. Oh god, this is like what I'm talking. That's what I was talking about earlier. It's like, how can you have an industry that is like so full of information but so useless? I don't get it. Like this doesn't. This is. I mean, this is actually a little bit better. Like at least it's talking about like architecture and stuff. But like, ay. But this is not system design. This is like product design. Offline storage. I mean, yeah. I guess this is okay. Yeah, I mean this one's actually okay actually. Like, it's like a fallback, like caching, eviction policies, throttling, debouncing. Yeah, this is okay. It's okay though. This is like probably an L4 level system design. Do I take any supplements or medications to help me focus when coding? No, I don't do drugs, man. Well, no, I do drugs, but I don't do drugs. You know what I mean? I don't take like I don't do meds like that. Just out of curiosity, but do you ever work on your own personal projects outside of work so you might have an idea that doesn't exist? Yeah, actually I do. So I think I've demonstrated this on stream before. So let me actually go ahead and show you guys something. Hold up. So like right now, this is a bot. This is a bot that I've written that allows me to value companies. So for instance, like if I want to do a valuation company, what a company is worth, I actually wrote a bot to specifically do that for me. And so like using these different valuation models, that it will actually calculate the price for me. So all this is like my own math behind the hood. This is not like grabbing it from an API and displaying it in Discord. This is actually a bot that I can use in order to try and value companies for me very quickly. So for instance, let's say that I'm valuing Costco. What do I think the stock is actually worth? Based on this metric, it's like only worth like $300 for me. But then cash on cash return, it could be worth like $400 in 10 years, like for some weird reason. And then also say, oh yeah, the book value of Costco, if you just like you take all its assets at face value and sell it off, it's gonna be 18 billion. And so like some of these calculations are just systematic. They're not necessarily right or wrong. These are just like automatically done for me. But this gives me like a filtering mechanism for looking at companies if I want to invest in them. So this is like an example of a personal project that I work on, and I maintain this regularly. So then, how do I prepare for junior engineers that are not so confident in system design? Junior engineers will never face a system design interview. They're only going to get object-oriented programming at best. So you'll never be asked to design something end to end. I have no idea who the hell is putting out the idea. Like who is saying that you need to do a system design interview as a junior engineer? That's never been the case. I don't know any company out there that does that. Like, there's not going to be an engineer. Like, what? Yeah. Oh, for an L4. Okay. So, how do I prepare? Well, if you read the guide, you'll know that I used DDIA and grokking the system design for actually for the backend engineers. But if you're talking about mobile engineers, this is just something I just use the principles from the system design interview and applied that to what I knew about mobile engineering. That's it. I just took the exact same principles. Like, okay, what are the trade-offs? Why does this problem exist? Why is this the best solution? How can we make it better? Like, literally, just that formula is all you need. It's very simple, but it's very hard to execute on it at a very good level, especially at the L4, L5 level. I would say, yeah, at the L5 level, it's a lot harder. Like E3 transition to E4, L4. Yeah, if you watch like my previous coaching sessions, you'll notice that I've basically just done that, where I tell the client to look at grokking the system design and then use DDIA. All these questions, a lot of the questions that you're asking, I've already answered in my guide. Oh, let's see. Acronym. Yeah, I don't think that like I don't think that there's like a good thing out. There's actually, if you're looking to like um, what's it called? If you're looking to actually do well, if you're actually looking to make a business for system design, or like, and you want to get in the information selling space, just do a mobile system design course. Like literally, if you can create this, and you can create this well, because right now I don't see anything that's that good right now. This one's actually pretty good. Like, you know what? I'm not gonna lie, this one's actually a pretty good high-level diagram. This is actually not bad. Not bad. Like, at least they're talking about dependency injections. You know? But I'm actually, like, this is not bad. This is not bad. I'm not gonna lie. But the thing is that if you really wanted to, like, sell some information and get in the information selling game for systems, for interview prep, like, mobile design is actually not a bad place. Like, there's no one, like, walking around in this, what's it called, in this area. So, if you want to sell some shit, go ahead. Sell some mobile system design prep. But good luck trying to make one that's effective. It says review at the end of the chapter, but it doesn't say what you do to review, but what? It says review at the end of the chapter, but it doesn't say what to do if you review but do it wrong. I don't know. I don't understand the question. How well should I know these questions? You're not supposed to know the questions. You should have a solid approach to actually, to actually doing the problems. That's what you're really looking at. Okay, this guy might actually be legit. He's actually talking about encrypted share preferences. Good. This guy's actually, this one might actually be legit. Geolocation, third-party SDKs. This is on device. Yeah, this one might actually be legit. This one actually might be legit. I think this guy might be pretty good here. Who is this guy? Who is this guy? Yeah, this guy might actually be pretty good. I'm betting this guy's probably legit. Let's see his LinkedIn. Staff software engineer at Google. Ha! Of course he's a fucking staff engineer at Google. See, I knew that this guy's legit. This guy's legit, man. Come on. This is actually really funny. Like, notice, like, oh yeah, this guy might be actually legit. Notice, like, it just took me like a brief skim of like the content that he's producing for me to recognize if this guy is good or bad. And turns out he's pretty fucking good. You know? If you're a staff engineer at Google, I think you're probably legit. So yeah, I'm gonna recommend this one actually. This one's good. This guy's pretty good. Huh, wait, where's the resources channel? I'll dump this in here. This guy's pretty good. What else we got? I think I opened up a few more. Yeah, this guy, yeah, see, this guy's pretty good. Okay, let's see, 15 years experience. I don't know. Explain data flow. I don't know. This one's okay. I mean, this is fine. This is okay. Like, it's basic. But this guy, I think this guy has some idea of what he's talking about. Yeah. Yeah, I think this guy has some idea what he's talking about. So he's probably not that bad. He's probably some kind of, he's probably legit. Let's see. Software developer in London. Let's see the resume. Engineering lead at Meta. Yeah. Okay, well there you go. Fang engineer. Ha. See, like generally, like you can generally tell, like, who the heck, like what the quality of the person writing these things, and then just double check and make sure that the person you're talking to, or at least reading the resources from, actually knows what they're talking about. So this guy's pretty, yeah, same. So I think this one's also not that bad, but I would prefer the other guys. This guy's actually, it's just a little bit better. So let's bring him on. here's his prep doc. Okay. Yo, hello.
Yo, man. Hello.
Hey, what's up?
I'm doing good. How about yourself?
Hey, doing good. Yeah. So, catch me up on like how your practice has been.
Um, it's been good, right? I like after the day of the replay analysis, I did like I would say the all like 2 to 3 hours only reviewing my questions, the questions I did in the past,
Yep.
and like doing those actionable fixes you said,
Uh huh.
and like internalizing this. And okay, and later on, and I just I did more exercises. I redo few of them uh, that I was stuck in the past.
Uh huh.
And as I mentioned, like for the general parentheses, now was kind of way more easier, like defining the clear rule sets.
Mm-hmm. Good.
And for the n queens, I would say that was like 80%. Was not like 100%. Still, I was trying to do some fancy things, like things that are complicated.
Mm-hmm.
But and one last thing.
Yep.
I was on grokking like this past day,
Mm-hmm.
and I perceived that even though like I'm considering myself much more easier to do recursion exercises and tree exercises. Sometimes it gets overcomplicated, and I I I saw this pattern of like being complicated repeated sometimes again. And yeah, I'm trying to like go into the question after I finished it, and yeah, where can it be more simple? Because when I look to the answer, yeah, it's a little detail. It's simple than what I did at some points.
Okay, so you have some
Yeah.
you have some overcomplications going on. Okay, that's fine.
Yes, I would say that. Yeah,
Okay, let me.
but
So,
other than that, yeah.
go ahead.
No, other than that, I guess that's the thing that is bothering me the most.
Okay, let's handle that one by one. So actually, let me boot up grokking here for a second, and we can go into like which problems you're struggling with. So the overcomplication part usually means that there's usually some detail that you've missed when initially planning the problem, and then you just end up like flailing around trying to figure out. When usually like it's just usually one or two things that you missed looking at.
Uh-huh.
Does that
That
sound about
makes
right?
sense. Yeah, that's pretty accurate.
Okay, so hold up. Which account do I have? Oh man, I have so many accounts. God damn it. Hold up. Let me log in, and then we'll look at a problem.
Okay. Just so you know, I'm on the tree depth first search like pattern, right?
Okay.
So I did like I'm in the last problem challenge, and yeah, I that's the only problem I haven't finished yet. But the problem challenge one I did, and all of the others I did as well.
Okay. How have you been?
Yeah.
So while I'm waiting for the two-factor authentication to kick in, let's actually look at this. So the bold ones are like the new things that you talked about, right? Test the code and the idea very thoroughly. Next time, use a list tuple to convert back to the list. Yeah, sure. Address this. Yeah. So a lot of these look very actionable compared to before. I think easily that a 5-year-old will understand. What would you say was the thing that really clicked in your mind?
I would say I can walk through now much more easy than it was in the beginning, but sometimes, as you mentioned, some little things I don't consider, which overcomplicated for me to do like a workaround, which is not that good.
Okay.
Yeah, basically, and one thing that I think that helped a lot is like don't rush in the end, even though it's pretty clear my idea is tested. I haven't like not rushing in the end, and which helped a lot. I even did like a mock interview with a coworker, and he said, yeah, he never saw like so much attention to details as I am now. But Yeah, I would
Good.
say that those little things on the on the approach made my idea sometimes get a little bit messy and overcomplicated.
Okay, so let me share with you
Yeah.
my. It's good that he remarks that you have attention to detail. That's a very good sign. But it's like you overcomplicating things usually means you've missed some observation. So let me share my screen and then you can talk me through what you did in grokking.
Okay. Oh yeah, the screen problem. I think I can follow on the live stream.
Okay, so what? So
Okay.
yeah. Last time we kind of lagged. So
Yeah,
tree
yeah.
depth first search, right? What's the problem that you did? That you said
Just a
you struggled with.
The problem challenge 1, and let me see other.
Find the
Hold
length of its diameter. Diameter of a tree is the number of nodes on the longest path between any two leaf nodes.
Yeah, and just a minute. I'm just verifying here, so I can remember the one that some detail I make overcomplicated. Yeah, the tree diameter one, and let me look at my notes. I'd say the count paths of a sum. Also, I struggle a little bit, and yeah, I think those two were the ones that I most struggled with.
Okay, so let's review this one. Tree diameter. So walk me through your thinking. And I'll tell you how I would solve the problem. I notice I've never done this problem before. So
Okay. So, it's on the practice sheet. I don't know if you.
oh yeah, the
if you
practice
want to-
sheet. Okay.
Yeah.
Let me open it up then.
It's actually the last problem there.
Okay, cool. Let me open it up. Basically, what I'm thinking is that when I look at this problem, I'm seeing okay, well, what constitutes the path in which they will converge is just the lowest common ancestor problem, because you can't pick like in example number 2 here you can't pick 1 even though it's a common ancestor, because that's not a diameter. It needs to be like a solid path. So 3 would be the lowest common ancestor, and then from there I would just calculate distance from lowest common ancestor to leaves. I think that's the one. I'm gonna guess that's the solution.
Yeah.
So that's and I'd have never done the problem before. That's just me going off intuition. So let's see, tree diameter. Go ahead. Okay.
Okay. My first thought, remembering what I did here, I kind of understand wrong, but I fixed that pretty quick, like in the first 2 minutes.
Yeah.
I thought that diameter was from last leaf, last right leaf and last right left leaf, but was kind of wrong. And I verified this pretty quickly that are paths, right? And what I thought was to check the most deeper node. I'll put like this: the most depth node from both sides, and +1, that is the current node I am at, and that's gonna be the path.
Sorry,
But,
repeat that.
for example, if I'm in the node 1, okay, I would check which is the depth, the biggest depth left, and the biggest depth on right. So in this case, it's gonna be 2, and the other case is gonna be 11 or 10. Doesn't matter. And take this sum of those 2 depths, greatest depths, let's put it like this, +1. That is the current node. That is the one.
Okay, that's not a bad. That's not a bad way of thinking about it. But then, what's the shortcoming of it?
I was kind of confused as how I was going to do this depth thing. It's kind of trivial because that's another exercise. How I would keep track of diameter, and soon I realized that I would have to have a global variable to at each level verify the diameter based on those depth, right? And my first, and I was at this moment, all right, just remind me about my approach. At this moment, I get kind of overcomplicating this. And but soon I realized that I would have this global variable, which helped a lot. But the part that I didn't like at all was I was passing the current depth. For example, if I'm in the node 3, I know that it's 1 level of depth. But to calculate from 3 ahead to 6, 9, and 11, I kind of have to reset my depth, and I was doing some. It's not complicated math, but to understand, kind of, how can I? It's kind of complicated to understand, to explain very for a 5-year-old child, as you mentioned.
Okay, that
And,
means that it means that the idea is not good. And so I
Yeah.
have enough data. I can make some comments.
No,
So
but one last thing.
Yeah, go ahead.
The grokking solution was basically my solution without considering this like this different thing. It was like just def left plus def right plus 1 was almost my solution, but mine was much more complicated. Yeah, only this thing.
Okay, I know what you're doing. So you had the right idea. The problem was that it was too complicated because you went for depth. Looks like they just went for height. So it's inverse. It's just the inverse of depth. That's it.
Yeah, I think yeah.
So it's like it got complicated because you're trying to go in and it's like, oh well, this is a depth of 0, 1 is depth of 0, 3 is depth of 1, 5 is depth of 2. But that one is kind of hard because it's not as I wouldn't say necessarily hard, in the sense that how do I describe it? It's that at the end of the day, you want the top node to know the height, the longest length that it can possibly reach, right? But what you're doing is you're going back in the opposite direction. You're saying, okay, well, with your approach, you only know the height once you've hit that leaf node, and then you have to pass that back up anyway and compare which is the highest height anyway. So it's like, why not just do it by height to begin with? You see, like if you look at like where things get complicated and you walk through like what you're doing step by step, it would have been like, hey, wait a minute, I'm just passing back height already.
Oh, yeah.
That's it.
I haven't considered this as and that repeated in the past question, like, and the other that is, let me check the name here. Count paths from a sun, which is like the basic, the same thing as you mentioned. If I counted like the height instead of the depth, would solve my problem, made like much more easier.
Yeah. So one tool. Go ahead.
No, that's it.
Okay.
Like much more easier.
Yeah. So one tool, and I've noticed this problem, like with the end queens, they like you basically keep trying to build up. It's like, well, I want you to try like thinking about inversion sometimes, not in the sense of like I want you to think about like working backwards. So instead of going like like at the end queen solution, you try building up the number of available squares, right? Why not take away since the number of squares that you can put the queens on is finite, you want to just take it away. In this case, it's more or less the same idea of inverting, where instead of trying to assign the depth to the leaf node, why not just assign the height to the parent nodes?
I haven't tried this. The problem is that I haven't considered like the height. It's a mistake. Yeah.
Okay, I'm gonna put that as a note here. Always invert to try and figure out a simpler solution. So yeah, I'm giving you another mental model to try and figure this out. Looks like I was wrong about the lowest common ancestor because I realized that would actually be requiring me to take every single lowest common ancestor of everything. But yeah, like good catch. You did a good catch on the just doing the height thing. It's just that one little trick that was kind of screwing you up. All right.
Yeah, that's it.
Okay. You said you had a struggle with count path, or did you feel like it boiled down to the exact same issue?
Was exactly the same issue.
Okay. Cool.
Because when I was trying to optimize this, first I did like a very not good solution. And then I was trying to optimize upon that. And let me just open my notes here. I know what I did. It was basically the same thing.
Okay.
Let me just remember what I was thinking here.
Okay. While you're doing that, I'm actually gonna move the problems to another sheet for you because I don't want it to mess with the prep doc. So give me a sec.
Okay. Yeah, I'm having like a practice sheet in like the other one.
Yeah, this is like our document for what's it called? For taking notes, but then having a separate problem sheet would be better. So let me go into that.
Makes sense.
Let's see. This is 2.5. All right. So then problem sheet. All right, and then I'll share with you in the chat. Okay, there you go. So that's the problem sheet we'll be working off of. And then here's just the practice. These are like our notes. Other than that, okay. So is there any other points that you want to talk about before we jump into it?
No.
Okay,
No
cool.
other points. I think that's it.
Okay, cool. So I'm gonna give you. I think that you're at a pretty good place with recursion. I'm gonna do one spot check, and then after that we're gonna move on to other content. All right.
All right. Sounds good.
Okay, cool. Let me bring out the timer. Okay, and then let me pull a problem out.
You're in problem sheet.
Yep, I'm looking at I'm looking at the problem sheet. I need to pull a problem out for you.
Yep.
Okay. Trying to find one that's. Have you done root to leaf with a specified sum?
Yeah.
Okay.
Yeah, I did.
Good. Okay. Let's see.
All of them except the problem challenge 2 I did on this DFS.
Yeah. Okay. Have you done compute valid number of IP addresses?
No.
Okay. So let's go ahead and do that.
That's a good one.
All right. So then here we go. So the problem I want you to do is compute the all the valid IP addresses of a number. So for instance, let's say I gave you 190.168.122, right? Well, the thing is that all the decimal places for these have been removed for whatever reason. So, but the thing is that this can represent 4 different IP addresses: 190.168.122, or 12.2, 190.168.12.2, 190.16.81.22, and 190.168, and then 122. So what I want you to do is, given this string, I want you to give me back all the possible IP addresses that this could represent.
Okay. First thing I can just to limit my scope of ideas here. I can consider that like a chunk of this of those 3 numbers cannot be greater than 255, right? Because it's like okay.
It's
So-
at 0 to 55. Yep.
Yeah. So because the pattern. Now, let me just walk through this. So, okay, isn't that? The first thing I can think here is basically try out all the possibilities. Since I know that there's not going to be no more than 3 algorithms, like 3 numbers to compound like a possibility.
Okay.
I would try basically all the possibilities. So, for example, we'll try one with the dot starting here and something like this. Moment. I need to have 4 portions. All right, just a moment. 4 portions. No, yeah, 4. Of with a value not greater than 255. Okay, then this is the basically the naive approach, I would say. Yeah, now let me just take this and I'm just gonna try to put in a tree of possibilities to see those results here being formed.
Okay.
Okay. So I first try to put this dot on the first this first place here, and then from here from here, I'll try all the other possibilities for the second
Sure.
dot. So I'll try from to here and so on, so on.
Mm-hmm.
But okay, like this is not gonna be valid. I'm just trying to see where it's gonna lead. This is not gonna be valid, and
Mm-hmm.
the maximum number of like divisions I can have is 4.
Okay. Yep.
Okay, so this is the second one. This is for the third one. Yeah, from that I will try. Since this is not valid, I will try for like the next, which is not going to be valid as well, and then from this one, which it's going to be a valid. Oh, there's an 8 here. No, it's not going to be valid. So yeah. So no, there is no possibility here. I can check that is valid. So
Okay.
I'll go into backtrack and yeah, just try starting from like I'll backtrack this entire tree. Try to start from the second. If I have one that is working, I can define a clear rule set. So let's say that I'm in this like
Okay.
in this place here,
Okay.
and I start to divide like one ahead, and yeah, from yeah, I just need to be very clear with the ranges. So up until the length of the string, and I'll try all the others. So
Okay.
hold up. That being said, yeah. Okay, let me try to define the rule sets.
Yep. Okay. Yes. I think you walked through it. I think you have an idea, but I want you to put it. Try to like put it in a way that a 5-year-old can understand. Like, what is your general algorithm?
Okay. Like you mean the pseudocode or like
Up to you.
can do a summary of it?
Up to you.
Okay. I think a 5-year-old will understand few plain English words. All right. Okay, as I mentioned, try to place all. Try to make. Yeah, try to do all 4 divisions. Until it is a valid. Until it's a valid one, meaning that less than 255 on the string, yeah, until it's a valid one, less than 255.
Okay.
Yeah, so basically I think that's pretty clear, right?
Sure.
And now I can define like how this is gonna happen, right?
Okay.
Uh,
I want you to reread that. Take a breather. Reread that sentence that you
Okay.
wrote. Does it still make sense?
Try to do all 4 divisions in the string until it's a valid one. Until each portion is a valid one.
Okay.
I'm gonna put
Sure.
each piece
Yeah, that's fine.
is a valid one.
Okay.
So yeah, pretty much. I must define a starting from the current index was 1 until the end. Until the end of
Okay.
the string.
Okay, that's fine.
The end minus 1, because it is nonsense to put like a dot here. Okay. I think that is the general idea. Is it clear for you?
Sure, but then what's the step by step that you're gonna do to generate all the 4 divisions? Because, that part is like I saw that you did it in your when you drew it out, but I want to know how you're gonna do it.
Yeah, that's what I'm gonna try to do now.
I mean, yeah. Okay, go ahead.
Okay, so look into this. Let me check one thing. Yes. Hold on a moment. I can validate only this part. No, I'm just trying to figure out. Okay, if I validate this part, it's a valid one, but the other parts are not valid. The other part is not valid. My problem is to go from this to the other part. Okay, let me check just to write precisely. So, okay, first chunk is valid. So I have to proceed with other dots.
Okay.
And then this is what I'm gonna do here.
Okay.
So
But
those
keep in
dots are
mind that
gonna
I
be
could have.
placed-
You said the first chunk is valid 190, right? Technically, one
yeah.
by itself would also be a valid chunk as well.
It's gonna be a valid chunk.
Yeah. So keep that in mind.
Yeah. Yeah, you're right. So okay, it's a valid chunk, as you mentioned.
Yeah, because
And I'll try for
keep in
this
mind,
method.
like, your bounds are between 0 and 255, right? So one could
Yeah.
easily be a valid chunk as well, not just 190.
Yeah.
So keep that in
No,
mind.
that's right. That's right. So I think like one base case for me to proceed here, it's if this chunk that I'm verifying is out of bounds.
Okay.
So this is gonna be like a blocker for me to proceed, I guess, and try the other possibilities.
Sure.
So that being said, I can like, if the current chunk is not valid, meaning that greater than 155, I will backtrack because there's nothing I can do here. And yes. Okay, since I need to keep track of like two things. Let me just check. So here I have this first one, the first dot here. I just need to know like the number of dots that I need to have. In this case, it's gonna be 3, because yeah. So yeah, I can do like kind of a decrementing. Yeah. So I will try to place. Oh yeah, actually, for the left. Oh yeah, on the left part. Like from the given index. Yeah, from the current index until the length of the string minus 1. I will then try like yeah, I'll try to place the other indexes. So but there's a missing part here. Yeah, okay, I place the first one and then okay, and then I'll try to place the others. I'm just checking when it's kind of okay. If I'm considering like if it's not a valid chunk, I'm not gonna proceed. And if it's a valid chunk, this means that part of it is right.
Okay.
So I need to kind of store store the valid portion. A valid portion. And yeah, store the valid portion. Okay. But there's another case when I finish like the traverse to place all the dots. So number of dots is equal to 0. And it's a valid portion because I didn't fall into this first case. I will then yeah, record, I think is better. Record the valid possibility to all the possibilities. Yeah, record the valid portion. Yeah. Yeah. And now just this part here, this is like a problem I have in those backtracking, like the indexes. I need to be very aware.
Okay.
Here. So current index. So if okay, since this is a valid one, imagine that I'm in 1, like I place 1 dot ahead of 1. And now I should place another ahead of 9. Ahead of 9. Okay, so
Okay, I get the feeling that you're stuck on something. This has kind of been for the past 5-7 minutes. What's going on here? What's going on through your mind?
I think the part of the index is like in create the divisions and like to move ahead. That's the real thing. So to recurse, like to try the other possibility and place the second. Because the part of like the number of dots I used, I can put something like number of dots.
Okay.
Minus 1, right?
Okay.
And then, but this portion that I'm doing here, part, I guess, I'm kind of stuck.
Okay.
Yeah. Record the valid portion. No, it's not.
Yep. Let me
Okay,
see if I can help you a little bit because I get the sense you're struggling. So, based on your thesis, your original statement, you want to do 4 divisions in the string, right? But
Yeah.
you need a systematic way of generating all those 4 divisions. That's what you need to focus on. You need to focus on systematically generating all of those 4 divisions in the string. Does that make a little bit? Does that help you a little bit?
Yeah, it helps. It helps.
Okay.
Okay. So yeah, as I mentioned, I guess let me take this. So I can do, as I mentioned, I can do 1 division here and the other here and the other here. So like to do this is like I have to just insert the dot and move all of the other elements 1 position ahead. Kind of, that's it. And then try the other possibility, doing the same operation of putting a dot into the position I'm at and moving, like, actually moving all the other elements ahead and placing a dot in the current position I'm at. So, yeah, insert dot current position. Then I'm gonna write like this. So move all elements ahead of index position of the current position. Place a dot in the current position. Okay. And then record this as a valid portion. Yeah.
Okay. So insert a dot on the current position. Move all elements ahead of the current position. Place a dot. I don't understand this one. Does it make sense to you?
Okay. Move all elements ahead of the current position.
Should draw it out for me.
Okay, so I have this sequence of numbers here.
Yep. Okay.
So
You insert a dot at the current position, which is that.
yeah, actually, yeah, like if I create one space to put move all of the elements ahead of it, and then place a dot here,
Okay.
That's what I mean. And when I go to the second position, I do the same. So it's gonna copy this is not gonna be efficient.
Okay, that's fine.
And place a dot here, and that's what I meant here. Had one position, one.
I get the feeling that you're pretty much completely stuck and you have no.
Yeah.
Okay, I'm gonna stop here. Because there's no point in going forward.
Okay.
Okay. So what do you think went right? What do you think went wrong?
What went wrong is that I was stuck in this point, and this is only the relation to derive all the combinations. It was clear how I need to do this, but I was not knowing how to explain a very simple way and do this actually in a very in a way that will work.
Yeah. So in other words, you had some intuition of how to do it, but you didn't actually know how to do it. So all you had was intuition, but you didn't have a clear idea. That's basically what that tells me. So let me actually show you. Instead of trying to troubleshoot your thinking, let me actually just give you something. Let me actually show you how I would do the problem, and maybe something will click here, right? So your initial idea is correct, right? Do 4 divisions in the string, and then make sure, and then once each of them are valid, then that you will accept that as a solution, right?
Yeah,
that's fine.
Yeah.
The problem is that, like we said, is to generate those 4 divisions. So what I would do is, if this was me, let me just move this here. Is I would say, okay, well, I need to generate 4 different possible ways of adding those chunks, right? So I would just start with this, that 190. This is not valid because this ending portion, we didn't hit the end of the string, right? And we because we are only allowed to have greater than 255. All these 3 different chunks are not. So, right? So what I'm going to do is I'm going to try this. No, this doesn't work. And then this doesn't work. No. So, okay, so I'm going to say, for the sake of simplicity, let's just say I'm only allowed to have 3 digits, right? 0, 1, 6. I'm not allowed to have 0, 1, 6, 8. Just for the sake of simplicity, right? So now I see, 8, 1, 2, 2. So, in other words, I cannot, because I've tried every single possible combination I can with this dot here, I know that these 2 dots cannot be here, right? So then I'm going to move this one over to next one over here, right? And try it again. Nope, this is not valid. Okay. This is not valid. Oh, this is valid. So now I'm gonna add this over, right? So all I'm doing is I'm planting my flag, or I'm splitting it at one point, and then I'm trying it at, on the second point, I'm gonna try here, here, and here. And the third point, I'm gonna start from that point as well. Here, here, and here. You get the idea, right?
Yeah, I got
The
it.
moment I drew that out, does that make sense?
Yes.
Okay. So, what's the difference between what I did and what you did?
What I did is I was first trying to place the first, like to compare the first chunk of the string in place like the first dot. And what you did is like you first place all the 4 dots and then check the last portion of it. And then if the last portion was not valid, you like redo the verification.
I wouldn't say the last portion, but it's like if the entire string wasn't valid.
Oh yeah, you check the entire string. So
Yeah.
it had a
So
different
basically,
approach.
the very simple way if I want to do this is literally just like was it 3 for loops, right? I would put the first dot at let's say I, and then I put the second dot at J, which is I plus 1, and then K, and then compare, and then I do the K plus 2, K plus 3, etc. Same thing, like, you know, and this is the I plus 2, and then I plus 3, I plus 4, and then just keep splitting it until I generate every single possible combination. That's a dead simple, easy way of doing it.
Yes.
So if I had to write that out in pseudocode, I would say, okay, split the string into 3 chunks, starting at I, you know, I plus 1, I plus 2, you know, or I say I, J equals I plus 1, and then K equals to J plus 1, right? And then so then for I range from 0 to 3, split get the chunk, recurse into the next chunk starting at I. So then that would be like J and that'd be K, right? And then we would terminate when, let's see, stop recurse when we have split the string into 3 chunks. Validate the 3 chunks. If valid, add to our list of possibilities, and then return. Do you see how simple that easy that was? And you understood that, like what I was doing at every single step, right?
Yeah, for sure, I understand.
Okay, so knowing that, compared what I just did to what you did, and like I want you to like try to see if you understand the difference.
Yeah. I think the biggest difference here is that I was trying to validate each chunk while you were like validating like all those 3 chunks. When you have 3 chunks actually.
I have 3 chunks. Yep.
Yeah, I think that's the first biggest difference. And the other one is I was trying to like record a possibility if the number of dots to place is equal to 0, like on counter here, and you are trying to validate. No, you're trying to first validate when you have 3 chunks, which is different than what I did. And the other thing is, okay, get the chunk recurs into the next chunk, starting at I. I think I was in the second part here. I was kind of going in the same direction, but you did this much more simpler than me. Yeah, I think I overcomplicated this beginning here.
I would say you tried way too many things. So
okay.
So I'm going to introduce the idea of doing one thing at a time, right? So in other words, let's retrace the logic of what I was doing, right? I think your opening of like, oh yeah, just do this, like drawing it out was fine, and getting the simple idea down was correct. The question then becomes, okay, well I need to do 4 divisions in the string until each piece is valid, right? So there's no difference between me validating it in the beginning and in the end, right? So let's say all I need to do is generate, because in theory, the underlying idea is generate all the subsets, or possible combinations of splitting the string, right? and then test, and then validate the strings at the end. That's all I really need to do. Generate the subset, generate all the possible combinations, validate each one of the combinations. And you try to combine that all into one step. And whereas this is like 2 discrete steps for me. And so that's
pretty clear. Yeah.
Yeah, that's the first part. And so now that gives me 2 different ways to focus on the problem. Generate all the possible subsets. That's what this portion is, right? And then validate the strings at the end. That's what this portion is. And so what you did was like you tried to validate while you were generating, which is where you got caught up. So thinking about the simple ideas at the let's see if I can like make this a little bit more explicit. Like give you a rule. Like you're only allowed to do one thing at a time. Divide things up into discrete, simple areas. Because in this case, the generation of the subsets is not contingent on validating it, but the validation is contingent on the generation, which means that I need to have the strings. I need to generate the strings before I can validate them. So why not just generate all the strings to begin with and then validate it at the end? Or at least in this case, once I've generated one string, then I can validate it. I don't need to validate it while I've already split the first chunk, because I have 2 other chunks that I need to deal with. So what I want you to do is like, okay, I want you to run with this. I want you to actually try coding this up to see if you really understand the idea. And if you don't, that means that I probably fucked something up, or in the explanation. But I want you to at least try to redo the problem. Actually, you know what? Yeah, try to redo the problem now that you have this insight, and do it as if you're redo the problem. Just do it as if you have this insight, and then show me where you run with it.
Okay, so I'm gonna do this right here.
Yeah, go ahead.
Yeah, in red, doesn't matter. So yeah, it's kind of very clear what to do. So
go ahead.
I'll put like valid IP and then receive like the regional.
Okay.
Okay. Oh, it's the other page. On the other page now.
Yep, I see it.
Now, since I have to keep track, like, let me just see, starting at I. All right, you need to keep track of the index. So this original function, I'll need to create a helper function to do this thing, because I'll pass like the possibility I'm trying, like, and the index that I have to start with.
Okay.
So this is gonna be possibility.
Okay.
And this is the index.
Okay.
That's pretty much it.
Okay.
And then here are the base cases. So stop to recurse when you have split the string into 3 chunks.
Okay.
But first split the string. Okay. Splitting the string into 3 chunks. Okay. Here you're describing what you're gonna do to split, right? No. Yeah. First you're trying to split.
Okay.
Is that correct?
I mean, I'm trying to split the string into 3 chunks and then validate it once I have a possible, what's it called? A possible solution.
Hold up. Just to be in the same page here. Okay, here we're gonna like do this first thing here. All right, in this step. Is that what I understand? It's the same thing as your meaning here.
I'm not sure what you're asking.
Like in this first step here, split the string into 3 chunks, right?
Sure.
So you're trying to create a possibility, right?
Yep.
Splitting into 3 chunks. All right. Okay, so you're doing this thing I was doing in the middle, you were doing beforehand.
Okay.
Right. Now you're gonna take. I'm gonna have the possibility. I can have like new possibility. This is where I'm gonna do the split. So I'll take the possibility the index, and then place a dot. No, yeah, I think maybe yeah, we can create a. No, I'm just confused.
Again? Okay.
How you? Let me do the other part that is clear to me.
Okay.
So, okay, when you have 3 chunks, so if maybe I can create a function to verify. I don't know. I'm just valid. No, that doesn't matter. Hold up. I just have too much ideas, and
Okay.
yeah, I'm
you
just
basically means you don't know how to you
Start
don't know how to do this problem. You don't even know how to generate subsets. That's what it's telling me. Do you know how to generate subsets?
I know, but I'm just is like the way you want this to be done, you know. No, but hold up. Let me do a step back.
Step back. Take a breather.
Because I can place the dots the way I was thinking, like
Okay.
to move all of them ahead and put a dot on the place. But also I can split and make 3 chunks inside one
Okay.
one possibility array. There's 2 ways of doing this.
Okay.
But
Pick one.
okay, I'll take one.
There's no point in combining 2 ideas if they conflict with each other.
Yeah. So yeah, it's because I was thinking ahead. Anyways.
Okay.
So
No. Yeah. Okay.
new
We'll talk about that later. Go ahead.
possibility going to be the possibility. Yeah, and then following your idea here of having I plus 1 and then a j plus 1 and those all of those things split into 3 chunks. Oh, hold up. To be index plus 1, then yeah.
You're not. I can tell you're not getting it. So let me actually show you the code, and maybe this will make it easier. Maybe if I show you the code, maybe you'll understand. How does this? Can you understand it now?
Okay. Just a moment. Oh, it's string builder. So okay, so far the size is okay. You create a portion to function to validate if it's valid, fair. Oh yeah, this part is the one that it's being splitted. I'm not understanding how this split's is working.
Okay, so let me walk you through it so that way, because I get the feeling that you've never seen this before. You've never seen how to do subsets before. So basically, so you understand the base case, right? Like, oh, if the S string is empty, and I have every single if I have if I have 4 chunks, right? Then then I'm gonna try building my string, adding the periods in between, and then add that to the list of results, right?
Mm-hmm.
And then here it's like, oh, if I have so if all my size here is if I've already gone through what's it called? This should actually be this would be 4. This is equal 4 whatever. It's like if I already have 4 chunks here and it didn't validate, then I'm just gonna return it out. I'm gonna eject out. I don't care anymore, right? That's what this part is. This part is saying, hey, yeah, okay, I'm just gonna grab the substring for between 0 to 1, 0 to 2, and 0 to 3, right? That's in this case, that would be your. Let me grab this. In this case, it would be 1. It'd be 1, 1, 9, and then 1, 9, 0, right? Those are the possible snippets here. And this snippet is valid, which just checks if it's a number between 0 and 255. Then I'm gonna add that to my list here. Right? And then I'm gonna take what I'm gonna do is I'm gonna pass in the substring. This whatever's remaining into here, into DFS. And then do the exact same thing again. And then
Yeah, that makes sense.
Yeah. That's it. So what this is telling me is that so walk me through like what the difference between what I just did is and then what you had in your mind. I'm trying to figure out like how to help you.
What I had in my mind is I was remembering like when you said that you're gonna place one apart of each other, like one distance of each other.
Okay?
And I was trying to like in this splitting the splitting way I was trying to do is from index plus 1. But I was trying to split in a very confused way. I didn't plan it at all.
This tells basically you just
I
don't
should
know how to
work on
generate
that.
subsets.
Yeah, I should have worked at that. Yeah, I should work on that. Yeah.
Okay. So if that's the case, then let me see if grokking should have a subset problem. Let me see.
One thing. For the exercises of like tree, was doing good. But those of subsets, those are like the ones that I was most struggling with.
Okay. If that's the case, then I'll have you do grokking subsets for this coming week. Wait, is there a subset here?
No.
Really? Wow.
Yes, no.
Wow.
Let me check.
That's interesting. No, yeah, there's a subset pattern. Yeah.
There is?
Yeah, there's a subset pattern. So I'm going to assign that as homework. All right.
Okay.
All right. Okay. So now that I know that, at least that's the next weakness we need to tackle. So if that's the case, then let's go ahead and do. Let's do another problem. But what I want you to do here, so that we're not like wasting this lesson here. What I want you to do is actually focus on doing one thing at a time. Something that occurred to me was that you were trying to do a validation and the the generation at the same time. I want you to focus on doing one idea at a time, okay? Because keep in mind, like here, notice like in the code, me generating the strings and me validating, and then me actually adding the dots were actually technically three separate things. I did not have to combine the dots into into generating at all ever. And so you can see here like, I just did my basic check here, and then I combined the list into a string, and then I did my generation down here. So notice that this arises because I'm able to think about this in three discrete parts, and I want you to think about that as well. I want to say I want you to think about like breaking up the problem into simpler, easier, bite-sized chunks. Does that make sense?
Yeah.
Cool. All right, let's go ahead and do it.
Let me just say one thing here.
Yep.
From this last exercise, I told you like the one on grokking, the tree one. I had basically the same problem. At first, the exercise was clear to me, but I tried to do so many things into only one step. And then since the exercise was much more simple to me, I'd say that was more easier for me to break down, and I focus on parts. But I guess when sometimes something that is not so something that I'm not having a good time deriving the answer. I tried to make this thing.
Okay, so you're saying that was the same issue that you had with the challenge problem?
Because first of all, I was trying to think how can I take the depth while like verifying the diameter at the same time.
Mm-hmm.
But then let's focus only on the depth,
Yep.
like the depth of right and left.
Yes.
Once I did this, I can check the diameter on like each node. So which make for me the approach much more easier. So, but I addressed the same problem as you said. Like, at first I was trying to do so much at once.
Yep. Just never do that. Always focus on one thing at a time. That's what first thing. And I really want you to try focusing on doing that for the next problem that we do here. Okay. Let me go ahead and pull another problem
I'll
out.
do it.
Let's see. We did lowest. I think we did. Did we do lowest common ancestor?
Yeah, as we did in the past session.
Good. Okay. Checking a binary tree is symmetric. Yeah, this one should be a little bit
no.
easier.
Yeah.
I think this one should be easier.
Yeah.
And we did root to leaf with a specified sum.
I did this like today.
Yeah, you
so,
did it today.
yeah.
Okay, right. Yeah, I'm just trying to scroll down and see if. I mean, we could do symmetric, but I feel like that's a little bit easy.
Which one?
Checking if two binary trees are symmetric.
Yeah, I think that's gonna be not so good to take me in a hard time.
Yeah. And then
Just be honest, man.
Yeah, did we do serialize, deserialize? A binary
I
tree?
think that's a good one. I think that's a good one because I have no idea how to do this.
Okay, cool. This one will be a good exercise in basically just you have to do everything. You have to do one piece at a time. If you do too much, you will get fucked. So, all right.
Okay, sounds good.
Okay, serialize and deserialize and a general NRA tree. So what I want you to do is, given a tree, I want you to convert it into a string, and then that's the serialization. And deserialization, I should be able to take that string and then convert it back into a tree.
Okay. So first things first. There's like two steps: serialization and deserialization. I'm gonna focus first on the serialization, right? So, meaning that I'm gonna have this tree, and I have to convert into a string. Is that correct?
Yep, you have a tree. You can convert it to a string. I want you to be able to convert it into a way that that can be translated back and forth. So.
Tree. Oh, okay. I need to consider this as well.
Yeah.
Convert to a string. Can be. All right. Let me just take this example here. No, actually, I'm going to start with a small case so I can think more clearly. So, starting with this very simple tree here. Okay. I can traverse to this first node, and at some way I can know which is my left child and my right child.
Okay.
So, okay, so here I am. Let's say I could track this on an array of numbers.
Okay.
Then I'm gonna let me think. Thinking maybe store then like in one of the ways of traversing the tree. It might help.
Okay.
Am I gonna help? So yeah, actually I need to address the child, so I need to keep track of.
Okay. Yeah. So how do you imagine you want to represent this tree? 1, 2, 3. How do you want to do this?
I need to know like the left and right child. I was thinking to put like 2 here, 2 in the beginning, and then 3 here. Right?
Okay. But keep in mind, I have a general n-ary tree.
Yeah.
So I can have 4, 5, 6, 7, 8 children, 10 children.
Yeah, let's say, yeah, right. Oh, yeah. Okay, then I can make kind of, uh, I was thinking about layers and like place this in kind of layers. So
What
for
layers?
example,
What layers?
for example, the first layer for the first children. So I know that 2, 3 are like the left childs, and yeah, this.
What do you mean left child? What right child? These are all. This is a node just has a bunch of children. Why
Oh
is it
yeah,
left or right?
you're right.
You examine the premise of the problem. I think you missed that. You're skipping steps. Slow down.
Yes, I need to keep track of this as well. Like all of the childs. Let me think. Yeah, I can have another inner element.
Okay.
See if that's gonna be too much complicated. So I can have 2, 3, and 4.
Okay.
That's it. And then, yeah, okay, just putting all of the childs here.
Okay.
Let me see if that idea is gonna work for, let's say, one more level. And let's say that the 4 have 6 and 7.
Okay.
Then I can have like, yeah, 6 and 7 here.
Okay.
That may be gonna work, but I need to check. Okay, every list, every like subarray that I place in front of one number, it's gonna be its childs. I maybe can have this convention.
Okay.
So for example, yeah, if I have one here, you know that, for example, I have a child that is 5.
Yeah, that belongs
And,
to 2. Okay.
Yeah, meaning that, yeah. Okay, maybe that's a way.
Okay.
Okay, so let me just move. Okay. Okay, that being said, let me move forward. Now I should to do this. So I can do, yeah, for each node, let's say I'm in the 1, I will take all its childs. So I'll take 2, 3, and 4 in like place then here. So like 2, 3, and 4. And yeah, so kind of like, let me write down. So for this node, take all its childs and place in place an array. And then yeah. And then when I am in 2, do the same thing ahead of it. Ahead. Position ahead. That works. Now I'm in 2. I will go in the first child, just like the same idea of a breadth first search, but yeah. Then first thing, being more clear, I take for this node take all childs and place in the position ahead, but I have to take the node as well. Take the node value. Take the node value and record. And the same node, I'll take all its childs and place ahead.
Okay.
Right, and I'll do the same idea for the second node.
Okay. Sure.
I just need to check if this idea is gonna be good to deserialize the tree.
Okay. Well,
because
whoa. Slow down something. Do you remember what is the problem right now that you just did? What was the cardinal sin you just committed?
Yeah, I'm serializing the tree. Serializing
No,
the
no,
tree
I'm
in a
saying
way.
what is the you made a mistake here. What was the mistake?
Okay.
Just pause. Think about it to what you just said in the last 30 seconds.
Take the node value,
No,
record.
no,
Okay, I said that we're gonna do this for the other nodes, for the child.
no. Do you said you need to check if it works with deserialization.
Yeah, I said that. Yeah.
When you haven't even confirmed that this actually works for serialization. Do you know why that's a mistake?
Because it's gonna take time, like for me to verify.
No,
The
it's gonna
deserialization.
take time. But what I'm saying is, do you remember what we talked about here?
Yeah. If that works, that really works. Yeah.
Focus
You're
on
right.
one thing at a time, and you're focusing on serialization and deserialization. At least get your deserialization working.
Yeah, you're right. You're right. Let me just yeah, check if that's gonna work. Yeah.
Huh.
So
I mean, like the way you proposed, you have so many like brackets here. I was like, why is there so many brackets? You know. At least get an
Yes.
algorithm down for it.
yeah, you're right. You're totally right.
Of course, I'm right.
Yeah. Yeah. Okay. Now, so take the current node. Current node value and to the even list something like this. All right, and yeah, like traverse to for all its childs. Yeah, actually, eight a new list of childs for all its childs. Record. Oh yeah. Append then in this child's list, and that's it. And but one thing, I need. Okay, that's good. But now there's like the childs I need to keep track of. I mentioned here. So yeah, append. Let's say yeah, just like a breath for search. So append current child. In the child's list. And then for current child, recurse
Okay.
the same operation.
Okay.
And yeah, but I just need to be aware of like what this recursion is gonna return me. So, like, I have to kind of take this. We'll have. Yeah, I call this given list, right? So I have to append this to my given list as well. Yeah. Append
Okay.
this result here, like that came recursively.
Sure.
And then, yeah, that's basically this for current child.
Okay. Yeah, try writing the code for it and see what happens.
Let's see. Okay. Serialize is gonna be receiving the root is, and that's pretty much it, right? The input. Okay. One thing I have to ask. There is no like restrictions in terms of how I would return this for you, right?
Nope,
I can
it's
return-
whatever you want to think is the best way to represent it.
All right. I was thinking about a constraint. It's going to be like a string or something. Anyways. So I'll call this helper receiving the node, and like let me a better name for this, like list. I'm gonna put like this, and then yeah, if right, I will take the current value of my node, so this node value, and then append to this node list.
Okay.
Yep, that's a very crucial part. So
Okay.
here I am in this first, and let me just do just if it's gonna correct. It's gonna be the correct representation of the ID. So I put this on the given list, like this first level here, and from this I will append all the childs of this, like let's say 2 and,
Okay.
and 4. Okay, that's what I want to do. Yeah, and that makes sense to pass this node list here, and yeah, and this.
Okay.
Now, I have to recurse. No, I have to, for all other childs, I have to do the same thing. So for
My question is, why node list? Why do you need to return a list? Why do you need a list? Let me ask.
because that's gonna be the result.
Okay.
Like, the result, this idea that I committed to see if that works.
Okay, so it's list a
that
string
make
or a
sense?
list?
List.
Okay.
Oh, that's a list.
I
This
will
node
let you
list
run with
is
this.
actually a list. Huh?
I'll let you run with this. Okay.
Okay. Yeah. And yeah. So one question about this implementation of the tree. I can assume that its childs are like in a list of references to its child.
Yeah, sure.
For each node I have a list, all right?
Yeah, each node has a list of children. Yeah, go ahead.
And so for child in the childs, right?
Okay.
I would, yeah, here's the, oh, yeah, actually, okay, here I have the child. I'm just gonna go with this because it's clear, but then I can optimize if it's redundant work.
Okay.
So I create this child list to hold like the way I want to do.
Okay.
That is like for each child, I'm gonna record like what the recursion result is. So because if I do this, like append the current child in this child's list. Yeah. So the same thing I said here, create a new list of each child. Then for each child, I need to, append the current child. And in front of it, I need to append like a
Okay,
list.
I'm gonna
that
pause
is
you
the
right here because
result.
I don't think you have any idea what you're doing actually.
Oh, I have the idea.
Okay, go ahead, write it. Because I
Okay.
don't think you do. But let's see.
I was just gonna finish it up.
Sure. Let's see.
Um. I'll, and then I'll take this. Then I will append the result of the recursion. So a helper with with yeah, with this empty list. And that's it.
Okay.
No, yeah, actually the helper is going to receive the current node, that is this one. Oh, actually here I need to receive the child that I'm traversing.
Okay.
Yeah, and that's it. And in the end, I have to take this node list that I just received here,
Okay.
and then append like this child ahead list.
Okay.
Yeah, I think was pretty much it, and then I'm gonna call this here. We're gonna receive the root. We're gonna pass the root and this empty list, and yeah, and should be the result. And okay, that's what I was thinking. Is it okay if I test this now, just to make sure?
I would have wanted you to test this idea to begin with, actually, but
Yeah.
sure. I don't.
Oh,
think,
yeah,
I
I'm
don't
gonna-
think this works, but okay. Try it out.
So let me take the same tree here.
Okay.
Okay. I'll in this first, I'm going to traverse like passing the root. That is the one,
Okay.
correct? And then I have 2, 3, and 4 that it's children's. For this given list, it's empty, but I will append this first node here. That is 1.
Well, let me ask a few things though. First, result helper. What is result?
Oh yeah. Yeah. Sorry.
Okay. You're saying you're gonna return helper, but helper doesn't return anything.
You're right. I need to return this node list. Now it's right. Now, okay, inside the node, I will create this child ahead, like that is a new list, right? And then for all its childs, I will traverse it. So I'll start from 2. The second node, I will append what this recursion is going to return. Imagine that 5 is a child of 2.
Okay.
Then yeah, I will to this given list. Yeah, to this. I'm gonna be receiving a empty list, which I'm gonna put the 5. Yeah, and yeah, it's quite disconnect.
Yep. You understand why I said that I don't think you had any idea what you're doing?
Yes.
Yeah.
You're right.
Yeah. It's because you tried to you didn't see the connection between all your ideas here. What ended up happening? So let me explain exactly what happened. So basically, you didn't run. You missed one step. Do you know what that step is?
Like the lists, I was maybe Oh. Let me just analyze here to give you.
Yeah, let's understand how we got here. The question is, why are we I see here we're passing in empty lists. We're not getting end results back. Like what are we doing here? Why are we doing it? We have all this big mess, but why did we get here? I want you to think back to every decision that you made. Why are we in this position?
Because first I commit to this idea of put listing into lists, list into lists.
Okay, but why?
Because that is the first thing I visualize how to organize the childs of each node.
Okay.
And yeah.
I'm gonna say it's because that right here, once you came up with the idea, you never tested it.
Oh, yeah.
You just came up with an idea and just said, oh, this kind of works, and then you just kind of moved on. I think you made the same mistake last week, if I remember right.
Yes.
Yes, you're doing examples in your head. Scroll down. I highlighted it too. It's the same mistake from last week. You did examples in your head.
Then yeah. I didn't test the idea. Why? Here.
Test your idea.
No, you're right. You're right, because it's way easier to fix on the pseudocode than it's to like think on the code.
Mm-hmm.
You're totally.
Yeah, and not only that, you're like patching random shit here and thinking it's gonna work. Oh, it works in my head.
Yeah.
Does it really work? Test your idea on the page.
Actually, I don't know if you have them. Can I just
What's up?
quickly kind of test this idea?
Yeah, go ahead. We have I
This
got like
idea
another.
work.
Go ahead.
Like make this idea work, then I commit to the code.
Yep. You should be.
Because
That's exactly what you should be doing. Not only that, remember what I said before. You need to be able to pass in this. I'm gonna give you a tree. I expect that back a string. Where's the string? All I see is a list. I don't get a string. So you lost sight of the objective. That's basically what happened. You just kind of said, "Oh, this kind of works. Let me just see how to get here." Well, it's like, well, why? Like, what? You know, just like, what purpose does each step serve? You're just kind of like patching and praying.
One question.
Yes.
At one point, I asked you like if the output should be a string or a list of lists. It was fine.
I said string.
String. You said string. Okay.
At the very beginning of the problem, I said string.
Yeah, there's no point of me doing list of lists. Mm-hmm. Yeah. You have done like basically the same idea, but passing kind of like constructing a list, constructing a string.
Mm-hmm. Yep. So go ahead. I want you to try testing your idea and try to fix this.
Okay, I'll do this. All right. Okay, now the first thing I will address is that I need a list, string actually, to give you a string that can be deserialized. So this thing of lists not work. But yeah, instead of like, let me imagine that this is instead of a list of lists, is just a string like this.
Yep. Okay.
Then we can. Oh, it's kind of confusing. Yeah.
Okay.
So now it's like the right output. And let me see how this can be generated. So there's no create list of children's. Yeah, it's instead of a list, I can take the current node to the given hold up. This part here doesn't make sense. So imagine that I'm in this tree, and I'll take this first node. So take the current node
Yep.
value,
Mhm.
right? And then append on the string,
Yep.
and on the string. And instead of like creating a list of all childs, I can like open a, what is it called? Like a bracket?
Yeah.
No.
Just call bracket. Parenthesis doesn't matter.
Okay. Yeah. Then. Yeah. Actually, this would help to know when it's null. Actually, there's no
Sure.
child. So I will then append a bracket uh to
Good.
to
I'm fixing this for you, by the way. So remember, be explicit about this. So
append the bracket to I'm just yeah, just being very objectively.
Yep.
Append the bracket to
Be
mark
be specific.
like like all the childs
Okay.
that it have
Okay.
right, and if I open I need to close. So after like traversing all my possible childs, I have to like close.
Okay.
Append a closed bracket actually.
Okay.
I mean, append a closed bracket
Okay.
to mark the end. To mark the end of all childs.
Okay. And then what are you gonna do about the stuff in here?
In the middle, so I have to traverse to all its childs.
Mm-hmm.
And instead of like append a child into a list of lists, in child's list, I have to, just append the current child to the current given string.
Okay.
To the current given string. Then that's basically this. And then and then for current child, I have to, recurse. No, I have to append the result of the recursion.
Okay.
So recurse to the same operation. That's pretty much it. Then
Okay.
after like, so for example, if I am in this, let me just. Okay. So
Okay.
I'm just creating this empty string here.
Mm-hmm.
And that is one. And then since I am open a bracket like this, I will put all its childs. So it's gonna be 2, 2, 3, and 4. No, actually it's gonna be 2 first. But since I'm gonna recurse to all the 2 childs, I'm gonna do the same thing. So there's like a step that doesn't work, because if I append the 2 again, it's not gonna work. It's gonna be redundant work again, and then here it's gonna be like 2 and 5. So that's wrong. I need to consider that I did this in the past. So let me just think
Okay.
how to address this problem. Yeah, actually, I can do this as a one-time thing,
Okay.
maybe. So for example, for this first node, I do this,
Mm-hmm.
then I'll check for all its childs, and then only for the first. Only for first.
I think you're guessing again.
No, it's not gonna work. Yeah.
Yeah, I think you're guessing. Walk through the walk. Just walk through it.
Okay. So first node, let me just get this thing here. Okay. So I'm in the first node.
Mm-hmm.
Have this.
And then you append a bracket.
And then I append a bracket.
Okay.
Then I can append the current node. Oh yeah, and then I append a bracket.
Yeah, follow your own steps. I don't get it.
Okay, and then actually
Why are you ignoring your own steps? That's my question. Why are you changing it right now? I don't understand.
Because this is not gonna be like a general case that's gonna work for its
Really?
child's. It's gonna be repeated work. In terms of, no,
Really? You know what? Let's put a pause here because I think you keep going back into your own head instead of drawing things out. So let's go. I'll walk through the problem with you and let's see. So I think I know what you're doing. So let's say we take the current value 1, right? Append the
Yes.
value to a string, right? So our string now has 1 in it, right? Append a bracket to mark the children that we have. Then so for all its children, append each current child to the given string, right? So and then for each current child, append. So we start with 2, right?
Yeah.
So then 2. So then we are recursing back into the operation. So then now append the value to a string. Okay. So
That's
then
a
now we see that, okay, this is actually what's screwing us up, right?
Yeah.
So then instead of doing that, why don't I just do this? Because now I know I'm going to do that here. In the recursion. And then append a bracket to mark all the children that it has. For all its children, mark append 5. And then close it out, right?
Yeah, and then close it out.
And close it out.
And go back to the other.
And then, then now we'll go to 3. And then open bracket again. Nothing. Append value because there's nothing. Close it out. And then now you have 4. So my question to you is, were you freaked out the moment it didn't become clear? It seems to work. I mean, it's not exactly like what you envision it, but it seems to kind of work, you know? So my question to you is, why did you freak out and decide to tear down your entire idea?
Because I just was not considered like to pass the value. I was thinking, where is the right place?
What do you mean, where is the right place?
Oh, I mean, like to don't be repeated. If I the fix that you made, that was what I was trying to think, and I freaked out.
You freaked out because you did it in your head. All I did was just draw it out. That's all I did.
Yeah.
And then don't do things in your head. All right. So I think we're gonna cut it off here because I think we've have enough to talk about. I think we have enough things that you need to work on. Focus on one thing at a time. Test your ideas on the page. Don't do shit in your head. If you can do that for me, that would pretty much solve most of your issues.
I have one question.
Yes.
Just like, how do you approach like when you have a situation like this? For example, your idea is like almost working. Like, so how can you be very how to say? Like, how do you test without like guessing? You know, like, oh, if I put this here, oh. I think that's one thing sometimes I mess up and make the idea that is like in the path to work, right? I did this thing that you said, like I tear down this and how do you like approach sometimes this? I don't know, it's one little thing that's one blocker, you know.
Okay. I just do it. I literally just you literally just saw me do it. All I did was just try it out on an example. That's it.
I didn't try this. And like from the example, express the idea, like where it needs to fix, right?
Yeah, exactly. It's just all I did was take your idea, try it on examples. Like, hey, wait a minute. I noticed that I'm appending twice, but I know that because of this recursive call, I know I'll be appending with the value here. So why don't I just take advantage of that? That's it. That's it. All I did was like, that's the only difference. The only difference is I tried it out in the real world, and you're trying it out in your head, which is leading to a lot of your issues. Like, the moment you do things in your head, and you don't actually try it out on pencil and paper, or in this case, the keyboard, you freak out, and you spiral out of control. The same thing happened in the previous problem, where you did the dots. You just tried doing the dots in your head, but you didn't really think about, hey, wait a minute, what are all the different ways I can generate the subset? And you didn't actually try it out. So, I want you to write all your shit down on paper. Like, when you do these problems, like when you come up with a naive solution, test it out on real examples.
Okay.
I really want you to do this. Like, really make sure that you run through the problem. Make sure you test out the idea. before you commit yourself to code.
Okay, it's gonna be must.
You have an idea that may or may not work at the beginning, but try it out, make an adjustment, try it again.
Okay.
Okay. I think that's enough for. Let's see. So I'm at your study plan right now. I'm going to say that for 212 to 215. What is it? 217. Yeah, I want you to do the subsets from grokking, chapter 7 strings, and really get in the process of drawing things out with this. I suspect that your recursion with the trees is okay, but I really want you to try drawing it out with the trees. Just at least try it out. Okay? And then if you have time and you kind of run out of things, which I suspect you probably shouldn't, but in case you do, I want you to try doing the binary tree, the modified binary search one.
Okay.
So the thing is that, keep in mind, the purpose of you doing these problems is to actually test out the ideas and practice everything that we've been talking about in the coaching sessions. I'm gonna be pretty mad if I ever have to repeat myself.
Okay. No, you're not gonna do this.
Yeah, I should not. If I have to highlight an example or something that I told you to do, but the week before, we're gonna have a serious talk, man. Because I already told you last week, you're doing examples in your head. Just try the idea out, and I had to repeat myself again. So do not make me repeat myself next week, okay?
Let me just explain one thing. Sometimes happen. Just being honest here. When I'm doing like the exercises, I follow like the step by step.
Yep.
I just took a note of this. So I draw it out. I did the test to make sure that this is working.
Yes.
And like I address where I can work on, as you mentioned. But sometimes I don't know. Yeah, this is like the actual interview scenario, right? When being tested, like sometimes it happened like in some mock interviews as well. Just skip steps and which make like behave poorly, you know. Do you have any tips for that as well? Like, okay, be calm, imagine that. I don't know. Do you have anything? Because that's a point, you know.
Be disciplined. That's it. It's literally just discipline. What you do in practice, you should do exactly that in the real world. That's the whole point of practice, right? It doesn't make sense to practice and then just not do what you practiced when it comes time to the actual thing. Just when you practice, treat it as if that is like the real deal. And then when you come here during the coaching sessions, just pretend like it's the real deal, like you did in practice. That's it. I don't really have any tricks for you, like, oh, should they calm down? Like, just do X, Y, Z. Like, no. Everything you do in practice should be what you do here. And, sometimes, like, it's like you might be in a stage right now where you need to be overly obsessive about the details. That's fine. That's gonna get better with time. But I'd rather you do that now than to, like, not make progress at all.
Right.
I'd rather you be very slow at solving the problem, being methodic, being very thorough, and then get the speed, instead of trying to skip steps now. In fact, skipping steps is what kills people most of the time. I think if you ask like Pavel or Valit, they got to that point where they started skipping steps too, and then they got completely crushed by it.
Okay.
The only way you start skipping steps is when you can be 100% certain that you know what will happen once you do that step. And you have not reached that point yet.
Okay.
So, I want you to be able to draw things out, test the idea, and go back over and over and over again if you have to. I don't care how long it takes, but I want you to be able to draw things out and be able to make sure that you get your ideas on the page.
Right.
Right. I think that's enough for today. Do you have any other questions?
No.
Okay.
No.
Okay.
Just one more thing. I think sometimes when like I clearly see how to solve the problem.
Yep.
I get I follow step by step.
Yep.
Sometimes when I'm in the situation of pressure and I don't know how to solve the problem, but I was like in an idea that maybe gonna work. Sometimes I just want to rush and I start to skip the steps that.
That's the opposite of what should happen. If you don't know how to solve the problem, you should be even more careful. Like, if I'm walking around in a jungle and I know at least, like, you know, I know the route I'm going because I've walked it 30,000 times before, I'm like, okay, I'm chill. I can stop, skip, jump, and run through the forest. But if I'm literally going to a place that's dark at night, there's probably tigers around, I'm not going to run my way through it and then make a whole lot of noise and hope a lion eats me. No, I'm going to be very, very careful. I'm going to be much more careful than, you know, than the path well trodden. So it's the exact same thing here. So I'd rather you be overly careful than not careful at all. And at that point, it's really about like you having the discipline to stick to what you've practiced.
Okay.
So, any other
Okay,
questions?
man. That's it. Oh, that's it.
All right, cool. Then I'll see you Tuesday. Let me know if you have any other questions.
Okay. Okay, man.
All right.
See you then.
See
Take
ya.
care.
Take care. Bye-bye.
Bye.
All right. Okay, so hopefully he does better next week. That was definitely, I think he's still making the same mistakes as before, but hopefully he does better. Sean says streaming during the day, long time no see. Yeah, man. I'm taking him on as a client. Hopefully he does well for his coding interviews, you know. And so yeah, that's why I'm streaming. Do I plan system design sessions since he is new grad? No system design because he's not L4, L5 level. You can't track multiple things in your head. Yes, exactly. Write that shit out on paper. I think I've done this. I've said this multiple times. Write it all out on paper. I have the same problem. The moment I'm doing the pseudocode or solution, I start doubting my solution, then get stuck in a thinking loop. Okay, if you start doubting your solution, test the idea. Test the example on pencil and paper. And then once you see that, hey, yeah, it actually like completely fails, then fix it. You know, why is it failing? What are the factors you didn't consider in your algorithm, etc., etc. And then you grow your solution from the naive solution to the optimal one. But you don't do it in your head. You do it on fucking paper. So that's it. And so that's why I'm like telling him, think objectively, don't do things in your head, test your idea on paper. So hopefully you guys learned something from this. I'm going to sign off on the stream, I guess, since there's no other questions. So hopefully you guys enjoyed that. I'll be streaming again next Tuesday, 8 p.m. Pacific Standard Time. We'll have these weekly sessions on Saturday as well. So hopefully you guys join me for these, and hope you guys, stick with me in the future. All right, that's it. Have a good day, and I'll see you next time.